Hi, welcome to this video tutorial. This is one video of a series answering questions from past exam papers. We will start with this exam paper, which is Edexcel 9-1, and it is 2017 non-calculator. So this is the higher paper, right? So without further ado, let's get started. So we've got question 1, question 2, and 3 we try to answer at the same time without interruptions. So let's do question 1, which is on scatter graph, and the question asks us to write down the coordinates of the outlier. Now the outlier, you should have spotted it. It's this one here. What I have to do is just give the coordinate for that one, and in this case it is 10 and 19. The type of correlation is a positive correlation. And estimate the number of hours of sunshine. So it's this one here. I went ahead earlier, did the line of best fit, and I made my projection horizontally and vertically to give this reading here, which is 13 hours. Okay, and does the graph support the weatherman? Yes, it does. So we're going to say it yes, because it is a positive correlation. Okay, so that's the answer to exercise 1. Right, exercise number 2, we need to write down 56 as a product of its prime numbers. So it is 8 times 7, we know that, and it is 7 is a prime number, 8 is not, so we need to break it down into its prime factors, which are 2 times 2 times 2 times 7. Alright, question number 3 now is you need to do this multiplication, 54.6 times 4.3. You can use the grid method if you want to, or any other method, that's fine, but I'm going to use this one here, the long method. 3 times 6 is 18, carry the 1, 3 times 4 is 12, and 1 13. Carry the 1, 3 times 5 is 15, and 1 16. That's the first line. Let's jump a line, start from 0. From 4 times 6 is 24. Carry the 2, 4 times 4 is 16, and the 2 is 18. Carry the 1, 4 times 5 is 20 and 21. Right, add the 2 lines now. You got 8, you got 7, 14 here. Carry the 1. That's give you 3 and a 2. Put your decimal point. Count 1 2 1 2. That's your answer there. Alright, so these are question 1 and 2 and 3. Next question is number 4. Alright, we start with question number 4 here from first. It is a question on area of this shape here, algebra area, or area with algebra. We need to show x squared plus 6x is equal to 1. So, and the area, the total area of the square, we've been told is 10 centimeters squared. So let's go ahead and do the area of this one here, which is 9. The area of this rectangle here, which is 3x. And the area of this one here is also 3x. And here is x squared. Let's add them together. I'm going to start with the x squared term. 3x and 3x give me 6x plus 9. This should be equal to this area 10 there. The next step is to subtract 9 to both sides, because I need to write it down like this clearly, because 10 minus 9 is 1. Okay, so x squared plus 6x is equal to 1, and that's your answer, right? Question number 5, is we need to work out the total length of the frame. So that's, we need to find the perimeter, which is in this case 12 plus 5, right, and then times it by 2, and that's 17 inside the bracket, double it, that's 34 meters. That's the perimeter. Now we need to find the diagonal, which is the hypotenuse of this right angle triangle. So we have to use Pythagoras. So we need to do 12 squared plus 5 squared, and of course square root the answer. And I give us the square root of, if you did this, you get 169. And you know the square root of 169 is 13. So the diagonal 13 meters. Add the two lengths, gives you 47 meters. And you need to multiply it by 1.5. Because the weight of 1 meter of metal is 1.5 kg. To get an answer, you should do this, alright? And you will get 70.5 kg. That's the total weight. Okay, next question is question 6. Alright, question 6 is question on straight line and parallel lines. Now, two lines are parallel if they have the same gradient. So let's do the gradient for L1. What is it? So let's call it M1. Now you can see the gradient is this one here, because all straight line equations have an expression will come in the form of mx plus c, where m is our gradient. Now in this situation here, in this scenario, we have the gradient 3 for the line L1. L2 is not straightforward. We need to make y the subject, so we need to first copy it down. I will copy it down, and then I will work out the gradient. So in order to make y the subject, I need to do plus 9x. Okay. And then I do minus x. Okay. Both sides. So I will have the 3y, I apologize, 3y. Let me just correct that. It's going to be 9x minus 5. And then you divide by 3 because you want y the subject, not 3y. So that gives you y equal 3x minus 5 over 3. Now you can see the gradient of L2 is also 3. So if I call it M2, right, it's going to be equal to M1, that one there, and they're both equal to 3. So we're going to say, therefore, L1 and L2 are parallel. Okay. Question 7 is a question on average. So we need to do it in 3 steps, maybe 4. We first find the total mark for the whole class. So to do that, we take the average, the mean mark or average mark, 60 times the number of all the students, 30. That is 1,800. Okay. Number 2, we'll count the total mark for the girls. That's 54 times 20, which will give you 1,080. Third step is to calculate the total mark for the boys. To achieve that, you minus these two numbers, and the answer is 120. That's the total mark for the boys. Number 4, do the average, or calculate the average by dividing by the number of boys, which is 10, and the answer is 72. All right. Number 8 is a question on standard form. We've got 7.97 times 10 power as a ordinary number. So the way to do it, the best way I find, or the students find, is to move the decimal point 6 places to the left, because we have -6 as a power. So let's do that again. Count together: 1, 2, 3, 4, 5, and a 6. Right, and then fill in everything with the zeros. Okay, so the answer for, I write it down here, it's going to be 0.345. Just check in. All right. Okay, that's the answer there. So let me just rub off this. We don't need it now. The working out. But of course, in an exam, you don't have to rub it off. Keep it. All right. Part B, you do calculation with standard form. First thing, do the number. Calculate the numbers first. So what I'm trying to say, do 2.52 divided by 4. Do that calculation first. Right. The answer is 0.63. I'm not going to go through how to get the answer, but you should be able to do it. Okay. And second part is you do we divide the powers together. That's 10 power 5 divided by 10 power minus 3. Right, so that is 10 power 5 minus 3, because you minus when you divide, all right? And minus will turn to a plus. So the answer is 10 power 8. Put the two numbers together, this one and the power 10, 0.63 times 10 power 8. Now you can see this is not a standard form. To make it a standard form, you need to have the decimal point between the first and the second digit. So I need to move it here, right, like so. So we're moving it to right one place, so we need to multiply by 10. So therefore we need to divide by 10 here to keep the value unchanged of this whole number there, the full number. Right, so basically the answer is 6.3 times 10 to the power of 7, and that is your answer. All right, next question is question 9. Question number 9 is a question on finding the original price. So let's do that. We have the price of a washing machine is £600. That £600, sorry, represent a percentage of 120. All right, because the VAT, 20% VAT has been added to original price. Now we need to find first. We need to find the price of 100%, right? In order to do that, we're going to do in two steps. First, we're going to divide by 6 here, divide by 6. So this gives me 600 divided by 6 is £100. So it means that £100 represents 20%. And then from here, we need to multiply by 5 to get £100. Sorry, 100%. That would represent the original amount. And we do the same thing here. We multiply by 5, £500. Right? So that's the answer. The question number 10 is a question on binomial. So we've got 3 brackets. So we're going to do it in 2 steps. We're going to do the first 2 brackets together. And that will give me x squared plus 3x plus 2. And the next step, I'm going to do this one here. I'm going to multiply it by the third bracket here, x plus 3. Take your time with this one, don't rush it. Okay, so we're going to do that one first. I like to jump a line, x3 plus, and then do this 2 here, 3x squared, and then do this 2 here. That's also another 3x squared. Okay, and then this 2 here plus 9x plus, now this 2 here, 2x, and plus the last 2 numbers 6. Again, I'm going to jump a line to finish off and tidy up. What I mean is to simplify or collect the like terms. With x a power 3, let's change it slightly, x a power 3, sorry, plus how many x squared is 6x squared. How many x? 11x. And how many? Just 6 now. And that is your answer to exercise number 10. Hi, this is question number 11 now. It is on turning point and reading information from a quadratic graph. So let's go ahead and do that one. The turning point is this one here, and the coordinate, you read it from directly from the graph. It is 1 and it is minus 3. Now the roots is where the graph crosses the x-axis. So let's do the first one, the negative one, right, which is my reading is negative 0.8, and the second one, you can call them x1, x2, but you don't have to. It looks like 2.8. I'm gonna go for 2.8 for the second root. For this one here, you need to draw a line 1.5, x equal 1.5. So you can draw it. I would go, let me just do it here roughly. It is going to be roughly my answer. And then from here, you need to draw or project it against the y-axis, and that is your reading. My reading is y equal minus 2.8. Okay, so I'm gonna take that. I'm happy with that. Right, question number 12 is on fractional and indices, and this one is a negative one. Let me write it down again. 81 part of minus half. Right, you can change this to positive by using the reciprocal rule, so, which is 1 over 81 a part of a half. Okay, 81. Now if you have a to the power of half, any number to the power of half, what does it mean? It means the square root of that number. And for that matter, same goes for the cubic root. A to the power of third means a cubic root of that number. Alright, so for this one we need to do square root of 81, which is 9, so the answer is 1 over 9. Nice and easy. Now we've got fraction and power, positive this time, but we've got 2/3. That's what we've been talking here. So we need to do the cubic root of 64 first at the top of the fraction inside the bracket. Cubic root of 64 is 4, and the cubic root of 125 is 5. Then you square or elevate to the power of 2, right? And that give you, this will give you the answer 16 over 25. Alright, so that's how you do them. I'll write it down here. Okay, for this one here, y is inversely proportional to the square of x. You write it down as a formula, y equal k over x squared. That's what it means. Squared of x means x to the power of 2. That's not the completed answer. You need to go and find the value of k. Where do I get the value of k? You get it from the table here. Which one? Any one. But use the easiest one. I'm going to use that one. Nice and easy. A whole number rather than dealing with this. Okay. So when y equal 9, k equal 1. Sorry, I repeat that. When y equal 9, x equal 1. So that is 1 squared. And you can see that gives me k equal 9. So therefore the formula is y equal 9 over x squared. Alright, so now I can answer question B. They're saying find the value of x, or the positive value, right, when y equals 16. So I'm going to use this formula. 16 is equal to 9 over x squared. So that gives me x squared, if I put it as a subject, we'll make it as a subject, is 9 over 16, right? So therefore to find x, I need to square root both, right? That gives me, normally with me plus or minus, positive and negative, you know that, okay? So, but they want the positive only. That's why I underlined it. So we need positive of 9 is 3, positive of 16 is 4. And that is your answer. Question 14. Question 14 is a question on ratio. The question asks to look at what fraction of all the shapes are circles. We've got circles and squares, and we've got some black and some white shapes, right? Let's do the first one here, okay? Do that one bullet point there, number 1. So I'm gonna write it down here. We got white to black. So I'm gonna label it white W to B. That's 3 to 7. Well, so write it down as a fraction because we want the answer as a fraction. So we can start converting it to fractions. So that is the white. All right, are 3 out of 10. And the black represents 7 out of 10. Now let's do the shapes here. So this one here, number 2. So we got circles, white circles. I'm going to write it down as WC to WS. White circles, WC to WS. So that is 4 to 5. Okay. We want the circles only, so we will be interested on this one here. What is the fraction of this one here? It is 4 out of 9, alright? So we're going to multiply it by 4 out of 9. We're going to do that, alright? And that gives me, right, the fraction of the white circles is 3 times 4 over 10 over 9. Let's cancel it down. This 2 will cancel down. This 2 here, if I divide by 3, you get 1. Divide by 3, you get 3. Here, divide by 2, you get 2. Divide by 2, you get 5. So let's do that. 1 times 2 is 2. 5 times 3 is 15. So that's the white circles represent 2/15 of the whole lot. Now for the other one is for the black circle. I'm going to write it down here. What do I write it? Okay, I'm going to write it down here. B, C to black squares. Here it is, number 3. I'm doing number 3, that one there. It's 2 to 7. So basically, we got the black circle now. That's the one I'm looking for now. It's 2 out of 9. Right? So I apologize. I'll correct that. It says 2 out of 5. So for the black circles, it's 2 out of 7. Right? And we need to multiply it with this one here. Okay? So we're going to do 7 out of 10. 7 out of 10 times 2 out of 7. See, these 2 can cancel out. These 2 here can cancel out. Divided by 2 is 1. Divided by 2 is 5. So the answer is going to be 1 times 1 is 1. 5 times, this is a 1 here because we cancel down, is 5. Add them together. 2 over 15 plus 1 over 5. That gives me, common denominator is 15. Gives me 5. Alright, because you multiply by 3 here. Multiply by 3 here. You get 3. 1 times 3 is 3. Added 2 is 5. And then you need to cancel down by 5. And the answer is a third. So let me recap. The fraction of all shapes, the circle shapes, is a third. Alright? Okay. So that is question 14. Next question 15 is on estimations. Alright? We want to work out an estimate for the height of the cone using this formula here. So let's go ahead and do that. First, let me put the measurements, alright, or the numbers into the formula. So the volume is 98, so we're going to write it down as 98 is equal a third times pi. I'm going to use pi at 3.14 and then times the radius squared. The radius is this one here. I'll put it in bracket 5.13, square it, and then times the height. Now it's the height we want to calculate or estimate. So therefore, we need to make it the subject. So let's go ahead and do that. So h is equal. So in order to make h the subject, we're going to use the inverse method or operation. So start by the inverse divided by 3, this one here. So it becomes times 3. So basically 98 times 3. And then because we've got multiply here, so we're going to do the inverse for those two operations, and that inverse will be divide. So that's why we do a fraction here. So we're going to divide by 3.14. As you can see, so far I haven't estimated anything, so I'm just writing down the numbers or placing the numbers. Okay, and then times 5.13 squared. Right? Now let's estimate. So I'm gonna, so basically 98 we round to 100. 3 will stay the same, unchanged. Pi 3.13, we're going to round it to 3. And 5.13, we're going to round it to 5. Of course, it is squared. So you can see clearly these two will cancel out. And you got 100 divided by 25, because that's what 5 squared is, 25. And so that gives me the answer as a 4. So the height of this cone is 4 centimeters. All right. So far so good. Part B, we need to say whether our estimate is more than John's calculations or less. He used a calculator to get an accurate to 1 decimal place, or sorry, to 2 decimal places here. Now the answer is, let's have a look at first at the numbers, what we did with them. We had the volume, we estimated up, okay, so we rounded it up. So for the numerator, okay, what did you do? We rounded down. You see, 3.13 became 3, and 5.13 becomes 5. So we rounded down. Okay. So therefore, our answer is more than John's, because when you round down the denominator, you get a bigger value for the fraction. Okay, so our answer is more. Okay, so conclusion, the answer is, more. Okay, so that's how you answer question number 15. All right. Okay, next question is 16. All right, question 16 now is an algebra question, is a proof algebraically that n squared minus 2 minus n bracket n minus 2 close bracket squared is always an even number. All right, so you have to do this algebraically. You cannot place in number or substitute number here to prove this type of question. So let's go first, deal with this squared bracket here, there. So let's do it first. N minus 2 squared is n squared, and minus 4n plus 4, right? So we're going to put this in here. Okay, so we have so far n squared minus 2 minus, I'll keep it inside bracket for now, and then I'll remove it. Do one thing at a time, no rush. So let's jump a line and move the bracket now. Now when you do minus and you remove the bracket, you get minus n squared. So here, when you move bracket, you got minus, and minus becomes a plus. So that's plus 4n, and this will convert to, or change to, minus 4. Right, you can see clearly n squared minus n squared. So the n squared will disappear, 0n squared. Now we have 4n, the positive 4n, and we've got negative 2, take away 4, that gives you negative 6. And you factorize this, becomes 2, and 2n inside the bracket minus 3. So that is, because it's multiplied by 2, regardless what the bracket is, all right? So it is always even. Okay, that's how you conclude the proof. Okay, because you have 2 outside the bracket. When you multiply any number by 2, you get an even number. All right, so that's why I wrote down here is always even. Okay, let's start question number 17, which is on probability tree diagrams. So we want to work out the probability that Ria takes one counter of each color. We've got 2 different colors, the green and the blue. Now the probability of getting, let's write it down first. The probability of getting the green, G for green, is what is it? 7 out of 9. 7 out of 9. And the probability of getting a blue, so I'm going to label it B for blue, is 2 out of 9. Let's do the tree diagram here. We've got 2 counters being taken from the bag, one at a time. So the first one, so I'm going to have a green or blue. Right, so that's 2 out of 9. Apologize. For the green is 7 out of 9. And for the blue is 2 out of 9. So that is the first counter. The second counter, it could be also either green or blue. But now, because you already taken one counter, so there is one counter less in the second experiment, if you like. All right, so it's going to be, you got one less green and one less counter overall, so you have a 6 out of 8, the probability of the green in here. And for the blue, you still have the same number of blue, which is 2, but again the total number of counters is 8, because we've already taken one counter from there. Okay, and let's do the second option. The similar thing. So if you take a blue, the first counter, and let's do the colors first, either green or blue. So it could be either, as now you have 6. Well, let me apologize. It's going to be either 7 out of 8. All right, or it could be 1 out of 8, because you had taken one blue here, so you get one blue less, so it's going to be 2 minus 1, which is 1, and one counter less, which is going to be 9 minus 1, which is 8. You can check this by adding the these two here. It should give you a 1. These two here, these two branches, add them together, the total should be 1, because that's the total probabilities is always add up to 1. Always probabilities add up to 1. Okay, now we want probability that here takes one counter of each color, so it could be green and blue, right? Or blue followed by green. So these are the two possibilities. Okay, so it could be either green followed by blue, okay, or blue followed by green. So let's do the first one, the first route. Green blue is going to be 7 over 9 times 2 over 8. That makes it 14 out of 72. For this one here, blue followed by green, it's going to be 2 over 9 times 7 over 8. As you can see, it gives you the same fraction, same answer. All right. So basically, when we do all, probability of event A or B, you add the probability. So we need to add these two here. Okay. So the answer to our question 17 is 14 out of 72 plus 14 out of 72. And the answer is 28 out of 72. And that is your answer. Do not bother cancel it down. Usually with probabilities you do not need to cancel it down. All right, next question is question 18. Okay, now it says the diagonal A, the blue one, D to B, this one here has an equation a half x plus 6. I'll write it down there, and we want to find the equation of the other diagonal, the red one here, okay, in this rhombus. Okay, now you should know one of the properties of diagonals in a rhombus. Okay, one of the facts is that the two, right, make 90 degree. What it means that the blue one, the blue line is perpendicular to the red line, or the diagonals are perpendicular. Okay, that means they meet at the 90 degree angle. Okay, so that is a good start. You should also know that two lines are perpendicular if the product of their gradients, okay, m and m prime is equal -1. It means that when you take the gradient of the two lines, you multiply them to each other, you always get a -1. So that's the little formula. It's quite handy, this one. Okay, so now we know the gradient of m. This one is half. I can use this little formula to deduct the gradient of the red line. I'm going to call it M dash, of course, or M prime. So what will be M prime using that formula? Okay, you could say, all right, make M prime is as the subject, so you divide both by M. Apologize. It's going to be minus 1 over M. Okay. All right. So basically, M prime is minus 1 divided by the gradient of M. The blue line is a half. All right. Now, if you did this, you could use the algebra for it, or the normal way of calculating fractions, or dividing fraction. So you get minus 1 divided by a half. You know how to do this, right? You change divide to minus, change the division to multiply, apologize, and then you flip the other fractions. And that will give you a gradient for minus 2. All right? So that's the gradient of the red line here, A to C. So that is great. We've got the gradient. Now, we know any straight line is always come in the form M, the gradient, X plus C. Okay. So for that red line A to C, let's call it A to C, the equation will be Y equal, now the gradient is minus 2, X plus C. Now we still have a problem here. We still have haven't got the value of C, the intercept. Now from the graph, I can't. It would be impossible. It is impossible for me to do it graphically, so I have to do it algebraically. How do I do that? Well, there is a clue that here he says the coordinates of A are 5 and 11. Okay, so we've been given this coordinate. I'll write it down here, 5 and 11. And you can see clearly that line, red line, our line A to C, passes through that coordinate. What does it mean? It means when y equal 11, let's write it down here, substitute, x equal 5. So we're going to put minus 2 and replace the letter x with the value of 5. And that will give us an equation to solve for C. All right, so let's do some more calculation. Minus 2 times 5 is minus 10 plus C. You add the 10 to both sides. So basically, if I jump back here or up here, so basically C is equal 21. Could be 0 there. Right, so that is the value of the intercept. Okay. All right, let's recap our equation for the diagonal A to C is y equal minus 2x plus, because it's a positive 21, plus 21. All right, and that's the answer. All right, question 19 is a question on vectors. I went ahead and did the vector plotted the point D so that we can have a look at this relationship here between O to C and C to D, and that relationship is written here as an equation: O to C equal K C to D. What does this equation means to us? It means basically that the two vectors O to C and C to D are parallel to each other. All right, that's very important. And we have also another information that the point X is halfway, or A to C. So we're going to use this one, and we'll be given the expression for X to D, the red vector here then. So let's get started and write down O to C here. We're going to focus on this equation. This equation will be our starting point. All right, now O to C is this vector there, so let's replace it. All right, K is the value with the constant we're trying to calculate. Now CD, we need to express it in terms of X to D. Okay, and and c to x. Okay, let's do that. So c to d, to get from c to d, you go c to x and then x to d. Okay, and you can see c to x is half c to a. Okay, because the point x, we've been told, is the midpoint of a to c. So let's write down that relationship. C to x is half c to a, and c to a, c to a, to get from c to a, you do co, which is minus c, then o to a, which is plus a. Okay, right, and then I expand this bracket, I get minus half c plus half a. So that's for c to x, which I'm going to use the expression for, and I plug it in here. What about xd? Xd has been given to us. It's this one here. So we've got everything, all the tools we need to get started plugging them here. So let's do, if I number this one, equation 1, that's our focus. Equation 1, we're still working with it. So c equal k, open the bracket, I'm going to put in the expression for c vector cx, which is this one here, plus half a, plus half a, sorry about that, half a, and then we got plus the vector x to d, which has this expression there. That's plus 3c minus a half a. Right? So let's simplify, if we can, this expression inside the bracket. I can clearly see half a minus half a, so that's good. This two will disappear, and I got 3c minus half c. You need to do that. Basically, do the numbers 3 minus half gives 5 over 2. So basically, let's recap. We've got k inside the bracket, 5 over 2 c. That's these two, right, added together. Now I'm ready to go and remove the brackets. Okay, so equal 5 over 2 k c so far. So let's write it down again here, down here. C equal 5 over 2 k c. Remember, we're trying to figure out or to calculate the value of k. Right, so basically you can see c and c will, this two here then can cancel down. Right, so you have, I'm going to write it down here, 1 equal 5 over 2 k. Basically, to work out k, you do the reciprocal of this here. All right, so basically it's going to be 2 over 5, and that is your value of k. All right, I hope this helped. Next question is question 20. Right, so question number 20, we have a simultaneous question with quadratic. We're going to number this one 1, this one number 2. We're going to make the y the subject in equation number 2. That will give us 13 plus 3x. And then we're going to square it. We're going to square both sides. Okay, that will give us 169 plus 39, 78x, and plus 9x squared. Okay, now we're going to put this bracket, or we can write it down with that bracket actually, into 1. So let's do it. 1. So we have x squared plus 169 plus 78x plus 9x squared is equal to 25. Okay, so now we need to collect the like terms. So we have 10x squared plus 78x, and we need to do minus 25 for both sides, and that will give us 144 equals 0. All the numbers here are even, so we can divide by 2 everything. Okay, divide by 2, this is 10, so we have 5x squared plus 39x plus 72. Okay, so this will factorize 5x plus and x plus. You have to use trial and error to work out the two numbers here. They need to add up to 39. The two numbers, after a few trials, you will get them 24 and 3, because when you do 5 times 3 is 15, add the 24 here, that's 39x, that's the one we're looking for. Okay, so basically we have 5x plus 24 equals 0, which means that x equal negative 24 over 5. Now for this one we're going to do, look at the value of y, we're going to put it into equation number 2, this one here, into 2 to get y, so I apologize, in this one here. Okay, so it's going to be 13 plus 3 bracket minus 24 over 5, and if you do that you will get common denominator is 5, so 13 times 5 is 65, minus 3 times 24 is 72 over 5, and that will give us minus 7 over 5. So the first pair of solutions are x equal minus 24 over 5 and y equal minus 7 over 5. So this is the first pair. The second pair will come from this second bracket here, so x plus 3 equals 0 will give us x equal minus 3, and we're going to put that into number 2, of course, to get y equals 13 plus plus 3, and then bracket minus 3. We're going to substitute minus 3 into this one here, and that will give us 13 minus 9, which is 4. So the second pair of solution are x equal minus 3, this one, for which y is equal 4, and that's how you do it. So next question is question number 21. Right, question number 21 is a question on congruent triangles, and we've been asked to prove that A to C is equal to B to D. Alright, so I split the two triangles here. You can see clearly A, B, C and B, C, D. Now we're going to use the to be able to say the two triangles ABC and BCD are congruent to each other. We will be using the SAS, side angle side property. Alright, so now we've been told that A to B, so the first side AB is equal C to D, or CD is clearly indicated in the diagram. The angle B, so now for the angles, we have angle B is equal to angle C. That we've been told or indicated in the diagram. Oh, sorry, it's been told here angle ABC is equal to BCD, and also in the diagram, of course. And the second side is the common side B to C, is equal to C to B is a common, okay? B to C is equal to C to B, right? It's common to both. Okay. So because of these three properties, 1, right, 2, and 3, so we're going to say triangles ABC and BCD are congruent. Okay, so that is very important. So there's only one conclusion, is that the angle A to C, so we're going to put also hence A to C, or AC is equal to B to D. All right, and that complete the proof. Next question is question 20. So this is the last question of the exam paper H1. It is a question on the cosine rule. Now we have ABC, which is an angle of 30 degrees, or being given that, which I join it here separately. There's another triangle here, has the angle alpha there, and two different sides, has 10 and 10. The A to B is X, and B to C is X. Now one thing you should notice is A to C is equal to P to Q, right? Okay, so therefore AC squared, let me just move it up a little bit, I apologize. This C squared is also equal PQ squared, because I need to use the trigonometry with no right angles. So we call it the cosine rule. So I need to use the formula. So basically for A to C, is this one here, it's better to look at it on this diagram. A to C squared, right, it's going to be x squared plus x squared minus 2 times x, all right? And of course times cos the angle 30 degrees. If I stay in the same line, I'll tidy this up, so I'll have x squared and x squared, that's 2x squared, and here also minus this 2 here, 2x squared, but it is times cos 30 degrees. Now that's what if you like, the game changer will come here and cos 30, because you can see the formula here, I don't have any cos 30, I have square root of 3. You can see there's a 2 there, and now other things, the x squared. But cos 30, you need to find the exact value of cos 30. We need to know them. Okay, it's a very good idea to know. Well, it is useful. Okay, to know this one is square root of 3 over 2. Okay, so we're gonna replace this by its exact value. We're gonna do it here. So I copy that down to x squared minus 2x squared times root of 3 over 2. Now this 2 here will cancel out, this with 2, not with this one, because this is a separate term altogether. So what would I get at the end? 2x squared, this term here, minus x squared square root of 3. That is a c squared. Okay, right, so let's do the PQ squared, okay, which is in the same situation, same formula, of course, going to be 10 squared. You can see where does that 200 come from. Okay, you can see there's 100, there's another 10 squared, which is this two here, 10 squared and 10 squared, and minus 2 times 10 times 10, and then time cos alpha. Alpha is the angle PBQ. All right, so let's stay in the same line and tidy this up and simplify it. 10 squared, 10 squared, that's 200 altogether, minus this 2 here, 100, twice is 200, and cos alpha. So basically, remember we said here, if I box it in, this is very important, that if we do this one, use it, it means we're going to equate this to this. Okay, so let's do that. I'm going to write down 200 minus 200 cos alpha is equal to this one here, 2x squared minus x squared root of 3. And of course you can see I need to find or make cos alpha the subject. All right, so first thing I need to do, I need to minus 200 on both sides. Okay, I do one thing at a time to avoid making any mistakes. So this 2 will cancel out, so I will have minus 200 cos alpha equal minus 200 plus 2x squared minus x squared over 3 all that over 200. Okay, sorry, I'm divided by minus 200. All right, so it's very important. Okay. I haven't divided by 200, I apologize. Okay, I'm going ahead of myself. That's the next step I need to do. Let me just remove that fraction. That's the next thing I need to do. So I now need to divide by minus 200. Divide by minus 200 here. And divide all this by minus 200. Okay, so let's do that. These two will eliminate each other, so we'll have cos alpha equal, now this will turn to plus 1, right? Plus 1 or just 1. Now plus and minus will give you minus, of course. And then here you cannot cancel down these 2 because we don't have a 2 here, right? So the only thing you could do is factorize. You take the x squared, which is a common factor outside the bracket, so you can factorize the top expression. So I'm going to say is minus, that minus sign here is been shifted and combined with this plus to give us a minus there. Now we have 2 minus root of 3. Remember we said we're going to factorize this. It means that x squared goes outside the bracket. I could have put it here, but I want to do it exactly like this one here. So that is the answer we wanted, or they wanted us to get, or to show, or to prove that cos alpha, or cos p b q, which is the same as alpha here, p b q, is that expression. All right, I hope this video helped, and in the next video we'll be doing the first foundation paper non-calculator. All right, till then, take care.